Hello everybody. Let's see if everything works fine. Let's see how much delay I have. Hello everybody. Let's see if everything works fine. So everything works fine. Okay. Hello everybody. Welcome to the stream. After how many thousand years? How many thousand years have been since the last time I streamed? Let me check. It has been. What? How many months? Oh, more than 2 months. What the hell? Yeah, that's not good. Anyway, I'm back. Hopefully for good now this time. We'll see. So welcome back to the stream. For those who don't know me, my name is Kilonalios. I come from Greece and I'm developing a game that has to do with voxels and Godot and Godot engine and sci-fi and No Man's Sky and all this kind of stuff, things. So I'm currently in the very early stages of the game, which I was checking the Steam Festival, and it seems that we have scars above. It's a nice game, actually. But for now, I will go to the documentation of voxel tools, which is what I use for Godot, which can be found here. It's made by a guy called Zilan. Oh, that's nice. It's open. Because some soccer words are changing. I don't give a shit. Yeah, whatever. Where are we? What is that? What is that? Do I have a message? What the fuck is that? Okay, who cares? Let's go to Steam. The last time was 11th of August. No, I think probably I streamed several times after that, but I haven't announced all my streams because we are in part 11 of the stream, and this one is part 8. So let's announce that. So actually, no, before doing that, let's copy paste that and go here and do a paste here. And go to, for those who don't know, this is my server, which is not very active because I don't have many followers. By the way, thank you for everybody for reaching 102 followers. I know I haven't been super consistent with my streams, but it's always good to see reaching the first milestone, which was 100 followers. The next one, of course, is 1,000, and see how it goes there. What happened to the Godot engine logo? Why has fire? What is that? What are these? Is it cancer thing? Something. I don't know what they did. Let's see the announcements. Godot 4. So we are close to Godot 4 actually. Godot 4 is what I'm using personally right now. I've been using Godot 4 for almost a year now, without exaggeration. Right? I'm one of the first users of Godot 4, if you include people that are not doing development directly in Godot, for example. But because I haven't been very consistent with let's see, where the streams exactly? Streams are here. So I haven't been very consistent with my streaming. Hopefully it will be more consistent now. I should be able to... It hasn't affected me so much when it came to, you know, the stability of Godot 4. So what I'm going to do is give it a try to rebuild my build of Godot 4. I have to take a look. Status. So I am. Oh, sorry. I will see the coding, see the Keyclops, which is my build of Godot, and then do a Git status there. Okay. How do I do a Git Info? How I get? I think it's Git log actually. Without that. Okay, so the last time I updated this was in 27th of June. No. 17th of September. But the main branch was last updated in 16th of September, okay, and the previous one was 27. Now, okay, that may be because that is an old pull request. Maybe it takes the date of the pull request there. Yeah, because it goes back to the 16th of December. So I think it takes probably takes the date of the pull request, which is fine. Okay, so 17th of September was the last time I updated to the latest master of Godot. It's really important to rebuild it to the latest branch of Godot because right now Godot is stabilizing. It fixes a lot of bugs because they're getting prepared to release the first stable version of Godot 4. So we're gonna do the same. We're gonna go here, see which one we are in Voxel. So we have to change the branch to master. So Git checkout master. And where am I exactly now? Okay, so we are in the master branch. Git status, Git branch, which gonna see all the branches I have available currently, which is fine. So we're in a master branch. And now I'm going to do, of course, Git pull. Actually, let me do a Git remote v, which is going to show me all the available repositories online. Okay, so I'm going to go and do Git pull Godot, which is the GitHub repository. And of course, I'm going to pull the master branch from there. So, my God, this is not super fast, so it should take a minute, but it shouldn't be that slow. Because I haven't updated for how many? 16 until today. We have one week, 27, 2, 3 weeks. I haven't updated for 3 weeks. So it shouldn't be that many. Okay, Git status to make sure that everything went fine. Everything went fine. It complains here about Ephestos voxel because they're not committed to the master branch, but that's not a problem. And then we could do a Git checkout to the voxel branch. This is a branch that I put my voxel module, which is from Zealand. Git check more voxel. We have to go to inside the modules. Inside voxel, which is the module for VLAN, which is the voxel tools, which they do all the nice procedural planetary generation, which I need for the game, and do a Git pull is going to directly pull from the master, and hopefully his master is not going to conflict with our master from Godot 4. Git status to make sure that there is no conflicts here, which is fine. So now we are in, let's go outside, back to the main directory. No, I didn't want that. Where we are now? Yeah. So we are inside Cyclops. And see, we are in, it's going to say that we have new commits in Voxel because we pulled the latest version of Voxels, but we haven't merged with the master. So first of all, we have to merge with the master. So merge master to see that the merge is going to go without any problems. Okay, Git status again to make sure that the merge didn't fail. Everything is fine. And now the moment of truth, we have to build the entire engine with the module of Voxel for the release so we can use it. So if everything works fine, if everything works fine, we should be able to build this without any issue. No, we have a problem. Release debug. Word value are editor template debug. What the fuck is that? What? Did it change the sconce build? No, that's not good. Invalid value for option target release debug. So valid values are editor, template release, and template debug. Why did it change that? Did it change that? Okay, let's go to the communication. I think they changed the way you build Godot. Okay, so let's put that there. And actually, let's make it. This is tweets, this is voxel tools. New tab. Okay, let's remove the new tab and let's go to docs. What the hell they did? It seems that they changed the way you build Godot 4. For whatever reason, someone thought a good idea. So let's go here and see how you build this. building, compiling. For Linux. What you changed? Blah, 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 blah. I have those things. I have those things. I have those things. Release debug. What the hell? I don't do anything wrong here. Why it says template? Wait. Oh well. Scones in value for option target release debug. Values are editor. Okay. Is the stream lagging? Let's take a look at the stream to make sure that the stream is working fine. So it says here, template release and template debug. Okay, let's take a look at this with the internet, because I'm sure I'm not the only one having this problem. Let's go in the internet, friends, and let's take a look at. I want to check the stream first of all to make sure that everything is fine. The stream seems fine. Okay, so let's go and take a look at here, and let's see. Am I the only one that has problems with Godot? Godot. Problem with when compiling for Android. Okay, no, I want something that is the latest. The last past month. No, nothing. Weird. That's weird. So I don't have this problem. Okay, let's go and do a scones. See which is gonna clean the entire build. And do a clean build this time. Okay, let's do a build SH. Nope, same problem. So where's the problem here? Reading scones file. So okay, so it's actually the Godot build that has a problem, not the module. Release debug. Okay, let's go to Godot repository and see if we can find the issue there. Godot GitHub. Why there's a problem with building? Issues. Executing. Oh. Okay, let's search for release debug. No. What the fuck? No one has a problem? Okay, let's go to online and ask that then. So where I go for online, Godot 4 is here. Oh, okay. So where values are blah 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 blah. Okay. Okay, so let's go and take a look at the file that creates these problems. So this one is in coding. So coding kickloops. There must be a scones files here. They're called sconstruct. And let's show that it opens with Visual Studio Code. And the problem he has is in line, blah, 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 this Radenia, 249. So, 249. First of all, okay, let's take a look at something. Is there no release debug anymore? Release debug. Oh, it has completely removed. So there is no such an option yet anymore. So there is a template debug. Now they have changed that. There's a dev build. And in target, they have editor and template debug. And what is exactly template release? Okay, so this one is a new variable target, compilation target, editor, template release, and template debug. So is it editor the one I'm using, or is it template release? This one compiles all the editor without the engine, or is this one the complete build? Which one is of the two? This is what I don't really like. And it's only mentioned one time only. It's only here. What the hell they did? Hello, Scorpion. How are you, man? Welcome, welcome. How are you doing? How's our things in Germany? Are you guys cold there? Is the cold reaching you there? Are you ready for the new cold? Oh, subscribe for 1 month. Thank you very much, man. Thanks for the sub. Wow, you are my first subscriber. You are my first subscriber. Wow, thank you very much. You're very nice of you. How are you doing? Ladies and gentlemen, my first subscriber is here and is my mod and my all-time online friend, Scorpion. How you doing? Thank you, thank you. What the hell's going on here? I got a founder badge. Yeah. Yeah, I actually have to play around with the badges. I have no idea how they work exactly. But yes, you got a founder badge. You're first. Nice. So probably I will have to play around with the badges once people start subscribing. I'm good so far. Only I slept badly last 2 nights. Nice. I take some Xanax because I have anxiety attacks sometimes and anxiety, and I sleep like a baby. And especially I sleep usually the times I didn't used to sleep, which was in the afternoon for 2 hours. And yeah, the last month has been a bit tricky for me. It has been all sorts of problems. I just recovered from a flu. Fortunately, it wasn't COVID. But yeah, this was an adventurous last month, this September. How you doing? I'm good so far. Only slept badly last 2 nights. Oh, it's only for 2 nights. Nice. So what we have here, ladies and gentlemen, is that Godot has changed its build system. And I'm very curious to see when. So this one happened 2 weeks ago. So it says here, the tools options is removed and target changes to use 3 new presets. So basically what I have here is, it's a nice plugin. If you use Visual Studio Code, it's called, regardless if you code in Godot or you do anything to do with JIT and commits, it's called JIT Lens, which gives me the ability to use, this one is called JIT Blame, which basically you can feed it a line of code and it can find the latest commit and display you the JIT log for that commit, which is basically the comment, the JIT comment. And here it says that the tools options is removed, so we no longer have tools options. I think the tools options was if you wanted to debug, if you wanted to build the editor together or not the editor together. So the editor was basically optional. You can have the engine only, and that was useful if you did try to do like a Godot server. So we don't have that anymore. I think what basically they did, they merged the tools to the target plug. So target engines to use 3 new presets, which match the builds users are familiar with. These targets control the default optimization. Editor replaces tools, yes, target, release debug. So the release debug goes to editor. So the editor is the one I need to use. Defines tools enabled, debug enabled. Wait, so if it's a release debug, why it's debug enabled? Template debug, replace tools, no. Target is again release debug. What the hell? And defines debug enabled again. Wait, what? Wait, so what's the difference? Because I'm coding a small Twitch chatbot and overlay a song queue for a streamer, users can add songs via command, and she can remove it again, and after she sang it on stream. Okay. It wasn't too hard, but I wanted to quickly implement it. Yeah, the problem with this, and this is one of the reasons why I don't put music on my videos anymore, is that if I want to upload the video on YouTube, the stupid thing, it gives me copyright notices and copyright claims, which basically they don't ban you, but they don't allow you to monetize the video. So you have to remove the video, remove the audio in the video, and then re-upload it, which is not a good idea because the audio contains the voice as well. So I decided to avoid putting music for now. If anyone wants music, they are more welcome to just go on YouTube and just add something in the background. I know that most people use music, but it's too much of a trouble for me. I'm thinking at some point maybe playing my own music if I start making music again. But for now, I decided not to put... I have some stream-safe music, but you have to be careful if you use this kind of functionality online when you're streaming, because if it's copyright music, you can get banned. You can even lose your channel on YouTube. Well, she sings those songs on her own, and she doesn't store the votes, I think. Who sings? She. Who is she? On her own, and she doesn't store the votes, I think. A small camera. I don't know who is she. And she can move it again. She sang it on screen. I don't know who you're talking about. Well, if she doesn't store the videos, that's fine. And you know, if you don't upload it, it's also fine. And I think you can do also cover songs. So karaoke is like doing a case cover song, which is not illegal. It's not really infringing any copyright because you do your own interpretation of the song. As long as the original music doesn't play, which is copyrighted, you are fine. But I don't know. You know, just I'm a lawyer, and even I find copyright law sometimes pretty much a pain in the ass. So what we have here is this comment. It's really crazy. I don't understand this. It says that so the editor replaces tools plus target release debug. So I think this one is the one I was using, and defines tools enabled, debug enabled, O2, which is acceleration flags for C++, template debug. So this one is for the editor. The template debug doesn't have the tools included, so that means no editor. I was using... Okay, let me actually take a look also at my build script. My build script should be somewhere... Here it is. Open with Visual Studio Code. So my build script was doing... No, I wasn't using tools actually. I was doing platform, Linux BSD, and target, and bits 64 for the release. So I have to change that now to feel for the new way of building Godot. So let's go back to the commit message. Come on. Yeah. A general streamer, I can link you her channel if you want to. Mostly she streams at night times. Okay, yeah, you can link. I don't mind links. If it's Twitch links, I can always check out. It sounds interesting. Yeah, I have seen a lot of people using chatbots for choosing music. It's really. I mean, if you have a playlist and they can only choose from the playlist, which is pretty safe. Or if you just do karaoke. Yeah, and if you see it's the one that sings, I mean, obviously it's not a problem. I guess it's a music channel, so that shouldn't be a problem. Okay, so this one is template release replaces tools no. Let's see the channel. Live Santal. Yeah, let me put it here. What? Oh no. Ah, she's German, okay. And what she's doing? Just chatting. She's doing just chatting streams. Okay. Ah, she's playing games as well. Okay. Nice. Yep. Great. Okay, so let's go back here. So it seems that our friendly Godot has changed the way it builds itself. Dev build is yes. Yep, mostly chatting and singing. Nice. Dev enable disables optimizations, enables generating debug symbols, does not define and debug. Why they complicate so much? So now they have one flag that is the target. Is it target? Yeah, it's target. Or you can name it compilation target or editor. And it takes these flags here. And then have another one, it's called dev build. And you can enable it on yes or no. And I have optimize, debug symbols, audio, production, debug, etc. Welcome, blah, blah. So this one basically is a build flag, so you can use your scons. Okay, let's take a look at the arc. Architecture analysis. Which architecture analysis is what? Architecture analysis. No, architecture analysis. Gonna try and find that. Ah, you have to go to platform with the import architecture analysis. Okay. So we have template release. Okay, so I want to go back to this one. The tools option remove a target agent to use 3D presets, which match the builds you're familiar with. Editor replaces tools, yes. Target. So I would probably go for the editor. So wait. The tools options remove and target changes to use. So this is target. To use 3 new presets. So the editor is everything, yes. The template debug doesn't use tools. And it builds the release debug again. Okay, so I assume here tools it means the editor. So this one is without the editor. I think the tools, I wasn't really setting the tools command because I think the tools command used to be default yes anyway. So this was why I wasn't using that last time. And tools no target release. So this one is just release. I think this one is the stripped down version of release. No, it's all debugs. That's the one I understand. Debug enabled. So all that's the debug builds. Okay, so if you want to do a pure debug build, you have to go dev build yes option. Defines a dev build defines dev enabled, disables optimizations. Dev build. That is confusing. But they haven't updated the documentation here. So if you go to documentation, here, what's documentation for? Yeah, so this one is the latest documentation. They haven't said anything. They still use target release debug. With this one is wrong. Documentation is wrong here. So when this changed that? They changed that in 2 weeks ago. So apparently for those that you tried to build Godot 4, they have changed the way you build Godot 4, but they haven't changed the documentation, which is not good. Okay, so what I'm going to do is go here, modify. I'm going to give the platform. I don't remember. The platform was Linux, BSD, blah, blah. I'm going to remove the bits. I don't think that's useful anymore. And this one has to go as editor. Well, this one, which is the target debug, let's go back and see how we do that. If you want to do a debug, you have to go to the dev build and do dev build yes option. So I have to go here and change that to, where's the debug? Debug. So let's go dev build. Yes option. I don't know. I hope that is going to work. Okay, so let's go back to the terminal. Let's try that again. And now that works. Okay, so not to everybody, the way we build Godot 4 has changed. You no longer do a target release debug. Nowadays you do target editor, which is not, I don't know, for some reason, the docs haven't been updated on that regard. Here, there's no update of the docs that says that I have to go with release debug. But where the plan? Lace tools to debug and debug server, which can be used. Okay, so this one provides editor functionality, which is why it has a tools yes, which was the old method. And this is tools no, which is basically headless. It doesn't have the editor at all. And then we have release debug, and release is what? Dedicate server games. So that all this documentation has to change. All this documentation is wrong. And I'm actually using the latest documentation, by the way, which is supposed to be, let's see if stable documentation has changed anything. No, there's no compiling here. Okay, let's go back to compiling for 11 build in Linux. User no, it still is release and release debug. So that's wrong too there. No, it's wrong. No, this is, they haven't updated neither the 3.5. I don't know if that, of course, applied to 3.5, but I can tell you that for Godot 4, which is this documentation, it's definitely do not work. It's not documented correctly. So this one should be actually editor, and this one is no longer needed anymore. Okay, and we have a problem. The problem is in voxel. In voxel registered C types, there is an error here which says, what's the error about? Editor plugin marked override, but doesn't override. So there's an override method here that is not overridden. Is this the only error? Okay, so basically what I do, I usually instruct the engine to rebuild again, so it displays only the error. So let's do a clear here, and let's do a release, another release, and then I will report that as a bug on the Voxel Tools website with the problem there is. Okay, so it seems to be, no, it's not the only error. There are two errors here. Okay, so we have here in voxel lettering, blah, 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 blah. So we have two overrides. Those is basically methods that declare in C++ that you can override them on a inheritance class. Actually, let me improve. Let's take a look at the stream. Is it stable? Yeah, stable, yeah. Seems to be a bit going up and down. I can always, why it's so fast? Okay, let's take a look at the stream. Settings, stream, audio, video. Okay, let's take a look. Here it is. Let's decrease the stream in 1500. So it's gonna decrease a bit the quality a bit here, but it should behave a bit better. Okay, so it seems that so basically what happens when you have an override on C++ is that you go to the parent class and you say to C++ which methods have the ability to be overridden on a child class, which is definitely something that is not a very normal C++ object-oriented behavior. In object-orientation, you're supposed to be able to override anything, any method you have on a parent class, but because C++ is very paranoid, when it comes to object-orientation, it says to you that you have to be explicit in which methods are likely to be overridden in a child class, in a class basically. When we say about a child class, we mean a class that inherits from a base class or from a parent class, or a superclass sometimes it's called. So if you inherit a method, let's say open file, and you want this method to change, to be different on the child class, because the parent class may be a general open file, a graphics file, but you want to make a child class which only for PNG files, and you want the open method to be different. So you have to override this method. You have to use the override keyword in C++ to be able to do that. But the problem, however, is that if you don't override it, C++ is not happy about it. And that's what happens here. So I have to go to Mr. Godot Voxels tools and tell him that his build has issues, as always. Godot Voxel tools, and we have to report this as an error. Godot Voxel and go here to the issues. If it's not reported yet, no, I don't see anything. What was the last time? That's actually, oh, that's too. Actually, this is too low. So let's make a new issue and say, what? New issue? And say, override method does not override creating an error and failure to build for Godot 4. So we can go here and we can say that a new error seems to happening with lack of override. Yeah. And go here. Let's open that as code. And let's go the command line and find what this one is one time. Copy that and go new issue. And then make another space here for another one, which is later gone, which is 53 again. So this is basically a problem with the voxel module, because it is happening in those files. It's voxel terrain editor plugin H. Yeah, from the looks of it, is the header file that actually has an issue. So let's alert Mr. Zealand that he has problems in his code, and usually his replies over a day. That means that we'll not be able to use the latest Godot 4 for this stream, which is fine. Yeah, and if he needs any additional information, he will alert us. I'm going to keep that there. Okay, and let's see what I have here. What is that? Okay, we have some. Yeah. Do I have any water? So what happened here is that I cannot play games on Linux because they changed glibc. Glibc used to have, I think, an option that was legacy option for using some kind of flag that supported old builds, and they decided to remove it at some point because it was going around. The problem, however, is easy added cheat, which is what is used on Windows, depends on that flag, and the port of easy added cheat that Valve has created for Proton, which allows you to play games on Linux, depends on this flag. So basically what they did was basically broke any game that we remove it with this flag, they give like any game that uses easy added cheat, which means that you cannot play Apex Legends anymore. I used to play Apex Legends very easily on Linux, and many other games, including Elite Dangerous, etc. So that wasn't fun. That wasn't fun at all. But you know, it is what it is. So, building-wise, it doesn't go in anywhere. It seems that we're gonna have to wait for Zealand to implement and fix this. And yeah. Where's the... Wait, what? Where's my... Okay, I have to go back for this. What is that? What is that? Is this a pull request? I have a pull request here. 22 days ago. What happened? Send in Ingress. Metadata, fix working directory calculation, blah blah. Okay, I have to take a look at this. This is an old project I have of mine that allows you to do, it's actually a pretty fun project. I have it here, which allows you to have, and I'm pretty proud of it because I made the GUI for myself, that allows you to use a Pomodoro technique. And I always, I made it in the language I was using at the time, it's called Faro. And it's basically based on Smalltalk, which is another language which is based on Lisp. Oh, I don't have any light. Let me give you a second to put some lights on. Okay. So that was the old project I had. And yeah. How are we doing instead of connection? The connection is a little bit more stable now. So yeah, that was the thing I used to have. Maybe I can show it one time. Probably I'll have to port it to the Faro Tor at some point. It has been 7 years I haven't touched this code. And after 7 years, I get a pull request. Well, to port to Faro 10. Probably I will do it sometime. Yeah, I probably will port it to Faro 10. So let me actually reply this guy. Thank you for the pull request. I haven't touched Faro for a long time, but I would love to port this to Faro 10 pretty soon. So give a bit of time, because I have other priorities right now. Priorities right now, but I hope during this month to merge this pull request and maybe, who knows, bring some new features in it as well. So this guy is an old-time Faro developer. He's very good. He's pretty knowledgeable guy when it comes to those things. So yeah. Let's keep the pull request open. I will always come back to this. Okay, I'll have to keep it in mind. So, yeah, so about, let's go back, Godot voxel tools, GitHub, Godot voxel tools, GitHub. And let's see, and go to issues. And here is my issue 7 events ago. Okay, so this is the voxel tools I'm using. For those who don't know, this is what I'm using here. I don't have to build Godot, so it doesn't matter that it fails, because I still can use the older build I have. So I can go here and open my own version of Godot, and it should work without any issues. And it shouldn't be much of an issue as well. So let's remove that, put it down there. Yeah, and there it is. So I have made this, for those who don't know. This is my prototype that I worked with the game. It is playable, I think, I hope. Why the hell it's so big again? Oh, wait, we have a problem. What happened here? What happened here was that they changed this method. Okay, so there is no method like this anymore. Do I use this anymore? Anywhere else? Yeah, I used also here. Rad to degree. Okay, so where was that? Okay, so let's find the one that is opposite. The opposite is degree to rad. Okay, so rad degree, it doesn't exist anymore. Okay, so let's take a look how we can replace that. Let's go to the documentation of Godot and code rad to deg. Let's see if we can find anything similar in latest. Okay, so it has one rad deg, which is what? Main script, okay. So there is a rad deg to here. Control find rad to deg. So they seems to be here. Why I cannot find it? So if I'm not mistaken, it's in the math module. Not in the tutorials though, I have to use the API. So I think it was in the API in math, if I'm not mistaken. Math, I think. AQL and math. Math. There is no math. What the hell was that? Okay, maybe it was in GD script. Global scope. Rad, they have changed it to rad to degree. Yeah, they have changed it to rad to degree. Okay, so this is a change. Rad to degree returns third. Okay, so we found it. So it's actually a rad to degree. Okay, so that means that degree to rad has changed as well. Degree to rad. Yeah, so degree to rad. So let's take a look. I don't see anything here. I see dB. What is degree to rad? Is it wait. What? Wait. Why the rad to degree is not here? Rad degree. But there's no degree to rad though. How is that possible? Okay, so let's say degree to rad. Is there a degree to rad? Okay, let's put it as 2. No, it doesn't exist. Okay, so let's put it as, I think it was deg to grad. Deg to. There's a deg to rad. But also, I don't think they updated the documentation very correctly. Anyway, let's fix that. What is that? It's here. So that supposed to be, what was the first time? It was here. So that should be replaced with control find and how you replace things. So edit, replace. Is there a replace here? How you replace things? Blah 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 blah. Go to edit, find, edit, convert indent. What the hell? Where's replace? Search. Replace. Here it is. Okay, so replace that to degree to rad, I think, if I'm not mistaken. So you replace that with that, replace that to that, replace that to that, and that's it. Okay, let's save that. Why? This is the bug that it has. What the fuck? Why Control S? Sorry, 1 second. What the hell? Oh, for some reason. Okay, what's the problem again? Degree to rad not found in base self. What? I'm starting getting annoyed. Okay, let's stop that. So let's take a look at this. Degree to rad. I think this is the correct one, right? Okay. Degree to rad. No, actually, no. It was actually a rad degree. The other one that I guessed. No, actually it fails. Wait. Degree to rad. So it doesn't. Degree to rad is not found in base self. Wait, did I fucked up there? Yeah, I think I fucked up there. I think it must be. No, it's not degree to rad. What the hell I'm doing? File. No, it's search. Replace. Degree to rad. No, it should be rad to degree. Replace. And that's it. And save that. Yeah, for some reason, maximize the window every time I save that. So PI is rad degree. So it says rad degree not found in base self. Stop maximize the window. Why you maximize the window? Okay. Rad degree is not found. Okay, let's go back to the documentation. What the hell? Okay, so rad 2 global scope, rad degree. Here it is. Okay, so it's rad degree. Ah, it's the rad to deg. Okay. So let's change that. Let's go here and do a replace again. And the rad to deg. No. Save that. And now look at this. It maximized the window. Why the hell maximize the window? Why? Why? What the hell is that? No, maximize the window. Every time I save the file, maximize the window. That's a bug. That's a new bug they had. Anyway, I have to rebuild to the latest version. Degree to rad, not finding stuff. So it has a new problem here. It doesn't find degree to grad. So let's find that. It should be on the same scope. We have degree to rad. So where is that? Okay. Okay. Let's see, degree 2. Is there degree 2 anywhere? No. How much deg 2? There is a deg 2. What the hell? Why can't I find it? Control find deg 2. Ah, here it is. Deg 2 rad. Oh, I'm blind. I cannot see these things. Okay, so let's go to the thing here. So deg 2 rad should change to this one. Replace. Deg to rad should change to deg to rad. Replace. And replace. And another replace. And nomads. And save that. And of course maximize again, because the bug. And let's see if now everything runs fine. And again maximize the plane. Okay, so let me give me a question. Theo. Yes, this. And let's go back. And everything works fine. Okay, we have the camera that works okay. It acts a bit weird sometimes, I feel. But overall, we can navigate through the terrain. This is basically what the voxel tool does, for those that are new to the thing. It allows you to build terrains and have a level of detail and be able to navigate on them, because I've tried to make a space game that you can land on a planet. Seems fine so far. Right. And okay, let's navigate from down there. The only problem is that I have to change also the roll mechanics here. Just want to see how good I am at rolling those things. the way that I want to roll. Okay. Wait, what? Okay. So you can see here, level of detail is a bit slow, which is kind of, yeah, bummer. But then, of course, yeah, you're able to navigate through the plan so quickly. It's going to be a bit of a, yeah. And I can go back to the planet, far, far away. There is a bit of a chopping effect, but overall I think it behaves kind of okay. This game is going to be pretty low poly, so I'm not going to be pushing the GPU pretty far. So yeah, I just want some easy way of generate planets and doing the basics. See, yeah, I think overall the camera behaves the way that I want to behave. I don't see anything wrong with the camera so far. It doesn't sit exactly on the rotation of the planet that I would like to sit. And also the problem is right now it kind of goes inside the planet, so which I don't really like. I don't want to do that. I want to be able to only sit on the surface of the planet. Right. I mean, I understand if the collision doesn't work with the first sphere, because I think the first sphere is not really a voxel sphere, it's just a simple primitive. But the collision doesn't seem to work well also with this one, because the camera clips. I think that may be because my height is only 2 meters, 2 units, so maybe it needs to be a bit higher than that. But I wanted to use 1 unit per meter, which is why I'm using only 1 unit. So I don't know why the camera clips inside. Is the camera supposed to be that big? But overall, the planet works fine. We can see that we can land on it. The detail is not bad. The terrain is not crazy. I mean, probably it's not that interesting as terrain. But I think overall, it seems to have a good effect. And we get we get the lakes if we want to. We get, oceans. We cannot go very far out of the oceans because obviously there's not a lot of depth. So that will make things a bit better if I think there's more mountainy and more depth into the sphere, inside the sphere, because right now the water seems like it's only a few meters in depth, which doesn't make any sense for a planet. So these planets are supposed to be, I think, like 1,000 times smaller than real planets. And the reason behind that is because if you try to make a planet of the real size, you're going to run in a lot of math problems because of how large the numbers are. And there's a precision problem with floats on any CPU. But the more precise you want to be, the more error you're going to get, because precision in floats on a CPUs are up to a point, up to a fixed point, which is why it's not a good idea to just try to emulate the entire solar system by using just floats. Usually, most developers using some techniques to allow them to have error-free problems with that. Otherwise, you're gonna be getting jitter, and yeah. So things will start moving like some kind of movement like that, for example, which is gonna be annoying for the user, of course, which you don't really want. Instead, you want this. You want a smooth movement, which is why I decided to go with smaller numbers and don't try to push it too much. Now, I'm not sure about the look right now. I want to go low poly look. I was thinking to make some kind of flat look. I think I find one way of doing that, but using a shader. But I wasn't really a huge fan of the look at the end of the day. So yeah, we'll see how we'll see. So what I was thinking to do in the next few days, once we resolve also the problem with building, because right now I haven't built the latest. Why there's 2 terminals? Wait, what? Why there's 2 terminals? So there's 1 terminal here, Another terminal is there. It's a terminal for opening the Godot. It's this terminal which opens Godot and reports the error here. Okay. So, yeah, obviously I have to resolve these problems here, the errors. I think otherwise, it seems the edging doesn't have problem building. So, yeah. Yeah, I think I'll take a break for the toilet right now and come back and play around with settings and see if I can make the planner look a bit more interesting. Let's take a look at this. So this is where, actually, let me take a look. I also would like to go back to documentation a bit and take a look at the documentation. I want to, because I haven't read the documentation for a long time. I don't know if they changed anything there. Yes, I will actually read the documentation today. So this one hasn't had a reply yet. I will keep that. Actually, I will keep that in a separate tab. Go back here and go to documentation. And actually, I will take a look at documentation one more time. So I'm going to break for 10 minutes, go to the toilet, and come back and stream for another hour, call it a day. See you guys in 5-10 minutes. Okay. Okay. Okay, so I'm gonna go today and take like an hour going through the documentation again and then end the stream. I want to make sure that I am up to date to the latest documentation and I haven't done anything stupid that needs to fix because, you know, after so many months of doing this, it's easy to get out of date with the documentation. So let's go and do that. How is this for you guys? How it's viewing this? I think the quality is pretty okay. So you shouldn't have a problem. Okay, let's start the documentation. Okay, so I actually thought to start putting also my sub goals. Let's see how I'm gonna do this without screwing everything up. So Linux browser. Let's call that sub goals, which how many subs I want to add. So thanks to Scorpion, we have the first sub today. And paste this. Okay, so obviously I don't want this to be so huge. So give me a second to fix that. Okay, let's take a look at this. Okay, I don't want to be that big. Or do I can do that? Actually, let me do that inside here. Wait, what? Okay, so I don't want to do that. First of all, no, I don't like that. So let's change that. So let's make that to 100. No, that the width, yeah. No, actually not 100. Let's make that 50 to 300. Oh, sorry, no, my bad. 50 to 300. Yeah, that should be more appropriate. But it's too small. Okay, let's change that then again to 100 to, I don't know, 600? What about now? Yeah, let's put it down here. Okay, let's see how that looks. Is it too small? And let's put my camera. Okay, let's see, where's the chat? Okay, so I can put it, I put it a bit, oh shit. Sub goals, let's put that there. Yes. Let's make that a bit larger. Let's take a look at the chat. I can check the chat a bit there. So how that looks now? Is it good? I think it looks good. I don't know, I'm not sure. So the chat looks good, maybe a bit small on a display. Yeah, I can always put it down here, what most people are doing usually. And make my... Okay, let's take a look where the chat is exactly. I probably will put it down here. Come on. Make it a bit larger. Put it that here. And put my face, my beautiful, amazing face, a bit smaller. Here. Or I'm too small. Probably too small. Okay, let's peg it here. And the chat, I will actually make the chat smaller because my chat... Oh, okay, it's not bad. Okay. No, I think that's fine, yeah. That is a bit fine. So there's not much... There's actually enough space for the chat. Let's actually test the chat. Test. Yeah, it's okay. Looks okay. So I think it's pretty visible now. Yeah. I don't know if I make it a bit smaller. I think it's a bit too fat. Because I think there's a lot of space up and down here. So let's take a look at this. Make it a bit smaller. Make that maybe 50. Yeah, I think I'll make this 50. Yeah, I think it's fine, this size. And then I can scale it like this. Yeah, that's I like this more. I think now it's pretty obvious. Yeah, I think there it's fine. Because it overlaps with my bar here. So that shouldn't create any problems. Okay. Yeah, I think that's fine. Okay. So, let's go about documentation. And let me actually zoom this up. Yep. That's fine. That's great. Maybe put it a bit there so it snaps to the end of the stream. Yeah, that's fine. That's great. Okay. That's fine. Okay. So, right. So, let's see what happens here. Right. So this is how you build the Godot voxels. Blah, 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 blah. Okay, I don't care about that. I know how to build it. And let's go documentation. So this is the voxel terrain. The nice of voxel tools, it has also voxels for those that want to do Minecraft things. So that's good too. And voxel viewer, the camera. I don't see anything different here. Okay. The spouse app goal is readable, maybe too small on smartphone, so we fixed that, I think. And then you said display. I think the goal size is good now. Nice. Okay, so I think the same. I think everything's fine now. So the nice thing about those voxel tools that I'm watching here, right? So the documentation I'm reading. By the way, this is a module you guys can compile with Godot, and it gives you the ability to generate terrains that are procedural for planet generation, for pretty much anything. But what he says here is that you can use the tool for generate any kind of mess if you want to. So you can use it for generate enemies or for generating static objects. I would say static objects is possibly better, because if you use it for generate enemies, you probably want to animate those enemies, doing complex animation like skeletal animation, which is going to make it tricky with voxels. Although voxels do allow you to generate a mess out of them, and then take that mess and makes have a skeleton or rigging, but that has to be very procedural and probably a lot more tricky. So this is a tool that can be used for a wide variety of reasons. Right now I'm using it for the main purpose of the tool, which is terrain. And maybe later I will use it for other things as well. So basically you use this tool, which is called voxel tools, to make some kind of No Man's Sky kind of generation. So you can make plants, and plants are important in No Man's Sky because they don't have any animation. And when they do, it's usually, you can say it's a basic deform animation. So it doesn't have any need of a skeleton. It uses, No Man's Sky also does creatures. Now creatures are more complex because they do have skeletal animation, because they can move their limbs, and they can move their heads. So what they did with No Man's Sky was generate the meshes. So the meshes are created by actually real artists. They are static meshes. And the meshes are the hands of the animals, the fingers, the face, the bodies. And then what it does, basically, it doesn't generate the mesh from scratch, basically. It just assembles a random selection of existing static meshes that have been created by artists. And the same can be said about texturing and animation, also is already created by artists. So No Man's Sky is not a fully procedural game, technically speaking. But with this tool, you can actually make a full procedural game. But of course, making fully procedural games is not a good idea because you lose a lot of performance. No Man's Sky has to run in an extremely old hardware. The game, as far as I know, runs on 1 GB graphic cards, and it also runs on a CPU. So much of the procedural generation of No Man's Sky, surprisingly enough, is on a CPU, not on a GPU. The same can be said about the voxel tools. Voxel tools currently are only CPU accelerated, so they run only on the CPU. But I've talked with Zilan, and he said that he hopes in the future to actually also integrate some things on the GPU. And as a matter of fact, voxel generation is very friendly, especially cube marching, which is similar to what he's using. He's using a language called transvoxel in this case, which is similar to cube marching. Because it takes every cube, which basically is every voxel, one by one, you can separate those cubes because they're independent. And if you can separate them independently and process them at the same time, this is ideal for running on the GPU, which means you can get acceleration of 30, 40 times faster. So we can get much more massive performance if that is run on a GPU. Of course, if you run things on GPU, it has some restrictions. You cannot edit the data at the same time. You have to edit the data at the same time. You cannot separately edit the data for every mesh. Then if you do that, for every cube, for every voxel. If you want to go from voxel to voxel and voxel to do specific edits, then probably you have to move things to the CPU, which of course is expensive. Because basically, if you run the voxel on the GPU, what you want to do is generate the voxels on the GPU, generate the meshes on the GPU, and directly load the mesh from the GPU to the GPU, basically. So you avoid the CPU connection altogether to avoid one of the biggest problems that GPUs has, and that is synchronizing with CPUs. Because they run on a different speed and they run on a different way than a CPU, it can easily have something that runs very fast on the GPU. And if you synchronize a lot with your CPU code, let's say you do physics, things that usually are run on the CPU, you can slow down your graphical generation considerably. And basically, your GPU acceleration becomes almost completely useless. So you have to be careful about those things, because if you don't do those things, let me put also my webcam a bit lower, because I think we have space here. So if you're not careful about those things, what's going to happen is that you will slow down your GPU, even though it's already accelerated. You end up slowing it down, and you end up having the same problems you had previously when you run everything on the CPUs. So that is what we call the CPU bottleneck problem. And this is why running everything on a GPU is not immediately better. And of course, another thing that CPUs have is that they are extremely fast when you do stupid things on a multiple CPU, on the multiple cores of the GPU. But if you try to do anything smart on one GPU, let's say you do a very complex calculation, individual cores on the GPUs run nowhere near as fast as individual cores on the CPU. The CPU cores are far more accelerated, they have far more instructions, they are extremely more flexible, which is why you see many coders ending up not doing GPU acceleration in code that you can learn on GPU, because they find out later on that yes, maybe for that specific things it's very fast, but overall the things I'm doing are more capable of running on CPU and running faster on the CPU instead. So obviously all that has to do with what we call profiling, which basically means that you use a specific type of tools that time the amount of time it takes you to finish one task on a GPU or on a CPU, and can actually give you precise timings for every function or every method you are creating in your code that may run on the CPU or may run on the GPU. So this way you have a precise understanding on how much time it takes to run code on the CPU and how much time it takes to run on the CPU or the GPU. And depending on what you're doing, sometimes CPUs can be faster than GPUs. So we'll see how that implementation is going to work on the GPU. I know that he's right now focusing on running voxel tools on Godot 4. So porting to Godot 4 is going to be quite a task, because Godot 4 still is a moving target. And we shouldn't forget also Godot 4 that is going to bring us, it has already bring us, I don't know, I haven't really tested, the ability of doing automatic loads, which means you can, because this code does its own load system, which allows you to have a level of detail of terrain. So if I go here, as I displayed previously, and I move back, you can see that the terrain is losing resolution the further away I go, and it's gaining resolution on the mesh the closer I go. So you can see here, I think you should be able to see on the video, that there is an automatic load system that this tool has. I don't think that this automatic load system is using the automatic load system of the Godot 4. So that is also very interesting to see if we can make this work as well, if we still are able to work that as well, and if there's any advantage of using automatic loads on Godot 4 compared to the automatic loading that it has for the voxel tools. So there's a lot of questions right now. Both Godot 4 and voxel tools are pretty much a moving target. But both of them are extremely exciting because they bring you a lot of dynamism, they bring you features now, automatic loads basically is similar to, it's not the same thing, mostly there's that system is a lot more advanced, but we're talking about Unreal nanites, which it's much more complex. I assume it's much more flexible and of course much more efficient because it's Unreal, and usually games in Unreal have to be photorealistic. So you get there an extreme amount of detail. As a matter of fact, in Nanite gives you pixel precision polygons, which basically means the polygons in Nanite are so small, it doesn't matter how much you zoom on them, always there's going to be one polygon per pixel, which means if you make one polygon per pixel, obviously nobody will be able to see the shape of the polygon, which is a triangle. So that creates a lot of high level of detail. But they use very similar techniques. I mean, Nanite uses also a form of voxelization, as far as I know. They use a remesher that we use in here in voxel tools. But of course, they're using much more advanced algorithms that allows them to do a bit more acceleration. And they also take advantage a lot of the GPU, which is something that the voxel tool doesn't do right now. And as far as I know, neither does the automatic load generation on Godot 4 as well. So that is the edge, I think, that Unreal has over Godot right now when it comes to automatic level of detail. But I think the next year, we're going to see more and more new features in Godot that come closer and closer and closer to what we see in Unreal. And I think Godot is going to become very, very good. It's not going to become quite Unity Unreal, of course, but it's going to be definitely much closer to what we see in Unreal that we see in Godot right now. So different level of details and automatic generation of level of details is a huge, huge deal for games and real-time games, especially for us that we want to do a bit more extra details of the games. And we are not interested in just making 2D games or extremely low poly games. If you do extremely low poly games, probably you're not going to be caring about level of detail anyway, because the modern GPUs can handle very low poly very easily, so you don't need to use level of detail there so much. So, what do we have here? Right, so explain what is voxel. For those that do not know, voxel stands for volumetric pixel, which is a bit confusing if you think about it. But basically, voxel is a cube. That's all you need to know. Voxel is a cube. Voxel is a way, the way we can use, centimeters to, measure length. You can use, or meters to measure length. You can use square meters to measure area, and you can use cube meters to measure volume. And a voxel is basically that. It's a way to measure volume, and it divides your scene, which can be, of course, many different models and many different meshes, into voxels, into areas and volumes of space that inside there, they contain part of those meshes. And the big question is, can we make somehow to generate those meshes using mathematics, and then find a way to take those find what those mathematical surfaces are inside, starting to cross inside with individual voxels, and take every voxel separately and use those math that generate the surface, find exactly the slice of the surface they have, and generate a mesh, which basically means triangles, means polygons, out of that mathematical surface. That's exactly how usually procedural generation works. And the reason why we prefer to use math is because it allows us very easily to add noise and division, multiplications, and all these mathematical calculations that they don't have a notion of finite detail, right? So you can zoom in indefinitely into them. As long as you put in the right numbers, you can zoom in as much as you want. It doesn't change the way that it processes the data. The data is processed again using the mathematical formula. So what the mesher is doing, the voxelaris is doing, is usually taking the math geometry, which is purely used generated math, and creating a mesh out of that. This is how the voxel tool works. This is how Nanite works in Unreal. And this is also how Blender geometry nodes works in Blender as well. So this is a very popular technique nowadays. It used to be not to be that popular because it's nothing new. Of course, voxel generation and procedural generation of graphics through mathematics is something that can be used back in the 80s when people were doing demo, which basically was small graphic demos that were writing in real time that were using assembly code, very low level code, and they could compress down to 30 kilobytes. One of the beautiful things about it is that you can compress things down to extremely small numbers of space, because everything is doing using simple mathematics. And for example, even No Man's Sky, for example, you go and see it, I think it's like 10 gigabytes of a game that naturally, if you take a look at Ark Survival or other games that are of similar resolution in graphics, there are hundreds of gigabytes in size in comparison. And the reason behind that is because No Man's Sky is using, of course, math to generate much of the geometry. But what most people don't know is still No Man's Sky depends a lot on static meshes, which explains why it's 10 gigabytes. Because if it was purely procedural generated, it probably will be 1 megabyte or even 1 gigabyte at worst case scenario. So it will be hundreds of times smaller than the average game. But of course, what you lose in hardware space, you lose in CPU performance. Something like No Man's Sky has to do a lot of tricks to be able to run on older CPUs, where games like Ark Survival, games that are several gigabytes, they tend to be not so careful when it comes to performance, because they don't waste as much performance. Displaying the meshes nowadays is not a big deal. It's not going to keep your performance, because GPUs have become so good at displaying meshes. But usually when you lose performance on those games, usually because of special effects, audio effects, and this kind of stuff that take a lot more performance to the performance hit in this case scenario. So yeah, that is the good side of procedural generation, is that allows you to generate on all kinds of meshes, and you can do all sorts of crazy stuff with it, but it comes with a performance hit on the GPU and the CPU, depending on where you accelerate it. But you have a lot of flexibility. You can generate thousands and thousands of meshes out of a simple a few hundred lines of code. And you can build an entire world by using a few hundred lines of code. As a matter of fact, if you go to things like Shader Toy, which is basically, it says it's a shader a website, but in reality, it also deals with automatic mesh generation. And you go to Browse, and you go to By Popular, which was here. You can find there's a lot of things that, this one is a popular one. Where's the other ones? Oh, I have to change the page. Hello? Okay, this is another one that I like to use sometimes. And this is another one. This is another one. So for example, this one is completely procedural generated. There's no meshes here, there is no texture here, there is no light here. Everything is generated using mathematics in essence. So as you can see, I actually created complex terrain with forests and all this kind of stuff. The trees are, I think, cones that are deformed using a sine wave. Then you have this one. Again, there is no mesh here, there's no triangles. You can zoom in this indefinitely, and you're going to see infinite detail. As much as you zoom, it's again generated using math. And as a matter of fact, they're using what's called special distance field, science distance fields, which is basically usually what we use in voxels. It's a very common mathematical technique that allows us to calculate space and calculate how space interacts with light and surfaces. As a matter of fact, these science distance field techniques are used by Godot to do global illumination, because these mathematics are used here for the mesh, which is not really a mesh, it's basically the 3D geometry defined by using math, for the light, for the ambient occlusion, for the reflection, for the global illumination. So all those is using science distance fields, which is the most common technique when it comes to mathematical generation. So this is purely mathematical, which not even No Man's Sky is doing this. No Man's Sky probably will use meshes that are already generated statically with artists, and then assemble them together in a random way, and try to use algorithms that allows you to, morph between one another. This one, however, is completely generated. This one is a simple shape. Also, everything here is a procedural generated. But what's really interesting is that the animation as well is procedural generated. So there's a lot of flexibility on the things you can do. And you have here, again, animation procedural generated. The mesh, again, there is no mesh here. Everything is as well using math. And the rendering technique they're using here is called ray marching, which basically is like ray tracing. The only difference is that ray marching is more suitable for science distance fields, for this kind of procedural math. So it tends to be a bit more precise, and it tends to be a bit more detailed with the cost of performance. Of course, all that comes with the cost of performance. As you can see, it's capped in 60 frames per second, although my monitor is capped at 60 frames per second, so that's one reason. You probably can run this faster, but generally you're not going to be able to achieve the frame rates you will achieve with static meshes because it has to do a lot of calculations. And all this is calculated on the GPU because everything here is a shader. So all that here, all this math you can see here is what is used to do the animation, to do the modeling, to do the lighting, and to do the texturing. All this is inside here. And then you have this one as well, which is one of my favorite ones, which means that you don't only use procedure generation only for making meshes, only for making lighting, only for making global illumination, but you can use it also for making what we call volumetrics in this case scenario, which is basically smoke. In this case, we're using clouds. This is a beautiful animation. You can actually see here that it can be used for going through the clouds of Jupiter, for example. And it's amazing what you can do actually with using a bit of math. Again, the math is not really crazy. If you take a look at it here, is only 150 lines of code. And all these 100 lines of codes is doing the simulation of the clouds, is doing the animation of the clouds, and also is doing the lighting and the global illumination as well, because obviously the light bounces around the clouds a lot, and that affects the coloration of the image, because the clouds, of course, just changing color. They're changing color along with the animation. So as you can see here, when we're talking about procedure generation, which is again what I'm focusing this stream, there is a lot of flexibility. We can use it for doing texturing. We can use it for doing meshes. We are using it for terrain. We can use it for planets. We can use it for meshes. We can use it for animation. We can use it for smoke. We can use it for clouds. We can use it for water. But yeah, at some point, you're going to have to put a limit to what you are using, because learning the math is a lot more challenging. It's not as simple as going around and pulling a vertex and modeling your favorite model in your favorite 3D package. There are not a lot of tools that they deal with that. Unfortunately, it still is pure code, and you can do it using shaders, or you can use it using a simple programming language like C++, relatively simple. So you have to know a bit of math and understand, but most of it is basically understanding how using a sine and cosine and multiplying things together is going to give you these results. So that is a bit also intuitive. There's an art behind it. There's a logic behind it why a sine can be converted to look more like a smoke, because you add noise and you randomize this noise, and you use things like fractional Brownian motion that allows you to control the noise, how random it is. So there's definitely a mathematical side to it, but also there's an artistic side of it. So the same way that I can go inside and explain you how Blender works, this is the button, the menu you have to use. So this is the mathematical side, obviously. You have to become also an artist. You have to go around and do a lot of those math again and again and play around with this kind of math until it becomes second nature and until you understand what it takes to make this kind of smoke, understand. And of course, this person took time to make this, probably took them, days to really come up with the right algorithm that didn't look like anything like that. So if I go here and change things here, let's say I do, what is that? That's the render, I think. So if I do 1 and change that, I don't think this is going to affect. So immediately you see I affected the color. If I go and find where the noise is, where the clouds are, that's the rendering algorithm. Main image is where the rendering takes place. So I don't think it's this one. So I have to find from my Willy Blend shader, iLerp. Okay, let's take a look at this one maybe. Let's say we change that to Synix. How that change the code. So immediately you see it really affects. We really have affected the color with now it's much more blue. By changing just a simple sign here, the colors have become a lot more saturated. I have no idea what I'm doing, by the way. I'm not saying that I know what I'm doing, because I don't. And I know where exactly it affects the shape though. There must be somewhere. Maybe it's here. Okay, let's see sine wave. Let's make that 175 instead. No, let's make that 1075. Sometimes you have to be a bit drastic. Yeah, the noise starts to change here a bit. Yeah, we can see the noise already start to change, becoming a lot more less detailed. Let's see 100. Yeah, so this is where you can affect the noise. You can see now already the noise becomes a bit more detailed. Let's see 1000. Yeah, that didn't make a big difference. Oh yeah, it makes. Look how much more fuzzy it is. So if I go back to 175, so we go back to the noise that it was, and let's go the opposite direction. Let's say it's 0.0.5. How that is going to affect the noise? Not much. So that doesn't seem to affect the noise very much. How about this to 5.8? Okay, so you can see here, this one actually affects the movement of the camera. It starts having a wobbly effect. I don't know, maybe it's also the movement, oh no, I think it's the movement of the smoke actually. It's not the camera itself. Now it starts seeming like a heart attack or something, like moving inside, you know, a vein or something. Let's see 50. Yeah. So that's too fast. Let's go 10, like 3, 2, let's say 2. So you can see the noise now starting to have a movement, like a construction, you know, goes inside and outside. So that's how it works. So you have to understand how the math works, and you play around with this kind of math and see how each function really affects the generation. We've seen we can manage to affect the movement of the noise, we manage to affect the texture of the noise, and we manage to affect also the animation of the noise as well. So you can do a lot of interesting stuff using these techniques. But of course, you know, making everything from scratch is a lot of time consuming, which is why I prefer to do things by using existing tools. And that's what Voxels comes into equation. Voxels generalize only on the generation of meshes. It doesn't do smoke, it doesn't do water, it doesn't do you know, materials and anything like that. But of course, you can use shaders to do some of those things. You can make your own smoke generation using shaders, etc. Because everything we saw earlier on with the smoke there, it was basically shaders. So you can actually apply that to a plane and use that inside your game, having the spaceship navigate through a smoke tunnel kind of thing, right? So another thing that it has, what I really like, is the ability to save voxels to disk. So basically what this thing can do is not only generate the terrain, but allows you to sculpt the terrain. So it has the ability to sculpt the terrain, like, you know, because one of the things I want to do with my game is offer mining. So you can mine the terrain. And of course means sculpting, making holes in the terrain, making caves in the terrain. And the big question is, okay, how we can store this information? Because the next time the player loads the map, we want, and it goes to the same place, like we see in Minecraft, you want, of course, to have all these things be persistent. You don't want them to lose them. You don't want to go back to the terrain and the terrain revert back to its original shape. So one of the things that it does is has the ability to save voxels to disk. So it can save this information to disk using something called a voxel stream, which is one of another great things about using this tool. So one of the reasons why I'm using Voxels is because it really has quite a lot, if you go here documentation, it has quite a lot of features for doing procedural generation. And I'm always wondering how I can use this to, you know, come up with my own procedural world. I mean, what exactly is going to look like? So right now I'm not really have a specific idea for the game because I don't know how well this tool is going to work, and I don't really know how well Godot is going to work in practice. So instead of going and say, I'm going to make a No Man's Sky game, or I'm going to make an Elite Dangerous game, which is very ambitious, I'm asking myself what I can do and what I can make with the tools that I have. And the only way to know that is, of course, by making stuff with those tools and starting making something that looks like a game, like I did here with as a first step. I did here with this planet generation, which is very simple planet generation. There's nothing special about it, but it is a good first step. It is a very good first step. We work also with the camera because we had a lot of problems with the camera, which now the camera works pretty fine. So the next days I will go through the documentation and I will start trying to make the planet be a bit more interesting. Again, I'm not trying to make here a realistic game. There is a lot work going to make something realistic. I'm not looking to make something that looks super cool because, again, there's a lot of work going to making something that looks super cool. My goal is to make something that looks better. Right? Simple as that. And my goal is to learn and understand how to use voxel tools, the module, as an artistic tool. And that will require a lot of practice from my side. And yeah, it will require a lot of work, right? So it's not going to be, it should take like a month or two to really get the hang of it and see exactly what I'm going to do. Example for a problem that I have right now is how on earth I'm going to do the water. So the question here, is the water going to be voxelized as well? It doesn't make sense to be voxelized because one of the goals I have in my game is I would like also to have underwater worlds. I would like to have creatures underwater. I would like to have civilization living underwater. Entire bases being underwater. So again, how are we going to do that with this tool? Sorry, you don't see that. So this is basically how it looks like. So how am I going to do this with this tool? How I can actually make something that's underwater? Again, another question. You can do that because you can go here. So basically the way that this works is if I go to my scene and I'm going to play and load, you can see here there is its own language, its own visual language that is responsible for creating this procedural terrain. And the nice thing about this tool is that you can use this visual language for doing geometry nodes kind of blender thing, where you can actually generate things procedurally. But you can also use JavaScript and you can use also C++. So it actually gives you a lot of options on how to express yourself and how to make something procedurally. Okay, I think that's good for today. This was basically a stream that I wanted to get back to on the horse, as they say. There's definitely a lot to learn. And next time I will come back, I will study on the documentation. I will probably be a 3-hour study of documentation. I want to go through the documentation and get a very good idea how everything works. And then we were going to start doing and experimenting around with building procedural terrain generation and improving the terrain generation and starting, hopefully starting getting into the meat and the potatoes of how to make a planet and how to populate the planet with plants, with rocks, with creatures, etc., etc. So thanks everyone for attending. Let's see if I can actually do a raid. Is there anyone online right now? Okay, let's take a look at who is streaming Godot. Is anyone streaming Godot right now? Because I see 2 people are watching, so maybe. Jackie. Why Jackie is not in my? Okay, let's raid Jackie because she's doing. Yes, she's doing definitely Godot. Jackie codes. So thanks everybody for attending. Again, a big thanks to Scorpion for a big thanks for Scorpion for the first subscription. He's my first subscriber, so thank him very much. I will never forget that, mate. And I really appreciate it. And yeah, see you guys tomorrow, hopefully. And we're gonna go to the documentation, and then we will start building stuff with these amazing tools. It's called Godot Voxel tools. Thanks everyone for being here. See you guys next time. Bye-bye.
Change theme, default theme. Socrates enters in position, Agape enters there. Socrates says hello. Biologic saying